All right. Good afternoon, everyone. I hope you've enjoyed a delicious coffee and returned well refreshed for our next speaker, Ondrej Sika, and his talk about passwords and secrets in Kubernetes, how to do it right. Please welcome with a big applause, Ondrej Sika.
Hi, and welcome on my talk about secrets, password in Kubernetes. I'm Ondrej. I do DevOps consultations, trainings, and I have a company which provides infrastructures, and we can help you with your way into cloud-native tooling, Kubernetes, and clouds. So that's my main focus. I have lots of training for lots of cloud-native topics from containers, Kubernetes, Vault, and so on. So if you want to talk more about my work and everything about the DevOps, I have a booth, so you can talk with me there. I will be there today and for tomorrow as well. Tomorrow I will have also a workshop for Argo CD and Cargo. So there will be workshop tomorrow. And I have a large team, or a larger team. I'm not doing everything alone. I have company, so we can help you with like some larger projects on cloud native or DevOps side. We have pretty standard stack based on Kubernetes and those cloud native tools. So we try to use as much as open source we can. This is the stack we use in Sika Labs. And as I've mentioned here, we use Kubernetes, we use HashiCorp Vault, and I will be talking about those technologies right now. So, secrets in Kubernetes. So, why we are working on this topic? The answer is pretty simple. We don't want to have this. We don't want to have secrets committed in Git repositories and store them somewhere like this. This is not super nice, it's not secure, and we want to have a better solution, not just secrets and sensitive data in Git repository. So our goal is get rid of static secrets, secrets from Git repositories, and we want to be ready for a GitOps approach. We want to use a Argo CD and all the GitOps tooling with some secure way how to manage secrets and the best way to get rid of the secrets at all. So how to do that? We will use Vault with Kubernetes, but there is plenty other technologies like Vault. We can store the secrets in some secret storage. I will be talking about like the generic version, so I can run this Vault on any Kubernetes, on-premise Kubernetes, or in cloud Kubernetes as well. And instead of Vault, I can use Azure Key Vault, or in AWS, I can use Secret Manager as well with the similar approach, but today I will show you the demo how to use the HashiCorp Vault for that. I will use native Kubernetes authentication. So Kubernetes and every workload in Kubernetes has a workload identity. Every pod has some service account and some identity tied with the pod. So I can use this pod identity to get the secret from Vault, and the secret in Vault can be static or it can be also dynamic. So I can, for example, request one-time password for Postgres connection, which is also useful. And I will not have any secrets in any Git or source code in the repository. So the goal will be like get rid of those static secrets and secrets in code base. We will also create a whole configuration by GitOps principle. So we will use Terraform to configure the Vault, and we will create some access control for the secret. So one application can obtain some single secret, and that's it. And we can do it on Vault or OpenBAL in the CNCF landscape. I will be using HashiCorp Vault, but for this example, it's basically same. we will integrate Vault with Kubernetes without any static credentials. So we don't even need a static credential to Kubernetes to Vault. We can integrate a Kubernetes OIDC to Vault. So Vault can accept the identity from the Kubernetes, and if the policy and identity match, we can obtain some secrets from the Vault, which is ideal. And we can do it both way. We can do it from the application itself or with some, for example, plugin to Kubernetes, like external secret. So we will create a secret, a Kubernetes secret from the Vault secret object like for us. And then we can use standard Helms for the connection to the application. So we will have basically no change to existing applications, but we can do it like both ways. So every pod has an identity. If you see here, I run some container with container inside Kubernetes. It's a single pod. And in that pod, there is a path, varan, secret Kubernetes service account and token. And this is a GWC token from Kubernetes internal OIDC issuer. And if you parse this token, you will see something like this. So in the token, you have the identity, you have the pod, you have the service account, you have the namespace somewhere here. So you can determine, you can figure out what is the workload identity, where is this running, it's this namespace, it's this service account, and you can use this this token issued by this Kubernetes issuer to access some external services. We will use this against the Vault, so we will set up the Vault to trust this identity, and if someone presents us with this token, we can obtain a Vault token, and we can get the secret from the Vault. It's very similar to other services, like if we want to access, for example, Azure, we will also use the issuer from Kubernetes here. So we will have the same identity. Instead of Vault API, we will get the token for the Azure Key Vault from the Azure API, and we can also get the secret to the Kubernetes from the other secret provider. The idea is basically the same. We have some trusted identity. We tie the identity with the secret provider, and then we can obtain some secrets from that secret provider. Here in Vault, we have multiple authentication methods. So if I install HashiCorp Vault, and I will have a demo, so I will show you how to do that. We can create an authentication method for Kubernetes. So Vault with this Kubernetes out is configured that if I use the correct Kubernetes issuer with the Vault, or internal in this case, so if I have a Vault running in the cluster, it will get the identity from runtime itself and allow me to authenticate myself with some role to the Vault and obtain some secrets. So I have a Kubernetes authentication method, and then I have some role in that method, so I can specify on which service account and which namespaces I want to be able to access this role. In this case, read namespace example, so I can read some path from the secret store by that role. If I am in the correct namespace, in this case, it's a namespace example and service account default, and I can have multiple many those roles. Here is a example of the Terraform policy, which I attach to the backend, to the Kubernetes role. So in this case, I've created a simple policy. I can list and read everything in the secret path, Kubernetes example, anything. And because this is a key value store version 2, I have to provide metadata and data here separately, but everything on the path Kubernetes/example/ whatever will be able to read from this row. So, and here I have a boundary to just a default service account, and the namespace is example. So if my application runs in the namespace example, it will be able to read those secrets. If my application will run everywhere else, if it will not be able to get the secrets. And yeah, it has to have a default service account, which is there by default. So how to integrate this in our application, in our workload? We have two ways. One is direct access and direct integration within our application. So if our application, for example, if we know we will use this kind of integration with Vault, for example, we can use some Go SDK. In my case, I use Go for that, and receive the configuration in the application itself. So in the application, we will have like few parameters. What is the role? What is the Vault endpoint? And that's basically it. And we can also use some external secrets, for example, or Vault secret operator, which will mirror the secrets from the Vault into Kubernetes secrets and use those secrets like the same way we can use any other secrets in Kubernetes. This is a simple example how it works. So you can see here we have a simple post request to the Vault API. So you can see here it's a Vault running inside the cluster in namespace Vault. So this is the login API endpoint. So you can see here we are calling the auth Kubernetes login, and we are using a service account token from the Kubernetes, and we are using the role. We have to specify the role. So in this case is read namespace example, and we will get a token, this one. So we will get like larger JSON, but we will use this token. This is the Vault token, and we can use this token to access Vault with some role. And in our case, we can read anything in the example path. So there is a secret called env, and in the env there are like two keys for just colors, so we can get the configuration here. We are also using this Vault integration not only for secrets but for some dynamic configuration, so we can just change the configuration in the Vault, and the configuration can be very easily accessed and refreshed inside the Kubernetes as well. So this is the direct access. We can use this, or we can use a Go SDK, for example. So we can see here we have a same thing basically in the Go. So we have a Vault client. We will provide a Vault endpoint. We can read the token, prepare the login. So this is also our role, and the rest is same. We will set the new token to the Vault client, and then we can get the secret here. So that's very, very straightforward. The other way is use some operator. We are using a external secrets IO. There is native operator for Vault, but this external secret work with basically every secret provider, so we can use the same external secrets against AWS, Azure, and so on. And I think it's, even if it's not Vault specific, it's much easier to use it than the native Vault thing. So we are using the external secrets, and the idea is we have the core principle is same. The external secrets use the some identity from Kubernetes, and it will call the Vault API with that identity, get the secret data, and it will create a secret. So here we have the external secret, which we map against some secret store, and the secret store is pointed into the vault in this case with specific role. And yeah, this external secret then create a Kubernetes secret, and we can access that Kubernetes secret from deployment, stateful set, and so on. So that's it. Here we can have a secret store. We have secret store and cluster secret store, so we can use cluster-wide connection. For example, in dev environment, we can create a simple solution. So we will create a dev secret store which can read all the dev secrets from the Kubernetes cluster, for example, dev/everything, and we can create a secret from any namespace. Or if we have like production environment, or if we need some more like tightened role, we can create a secret store which is inside the namespace. We will point it on some vault. We will use some specific role, and then we will create a external secret, which is the like mapping for the Kubernetes secret to some secret store. So we are choosing this secret store. We will create a secret called env, and we will map everything in the path, basically in this path. So we will sync the secret object from vault on the path example env into our secret. So that's the idea behind the secret operator. We can use this inside a Argo CD. So if I have Argo CD in my code base, there is only the external secret, and the external secret creates this secret. There is an owner reference, so Argo can visualize that. And if you see here, there is no sensitive data in this YAML, so you can have this in Git, and it's fine. So I will show you a simple demo. So let's have the demo. Okay, so I have a demo here. So it's on GitHub. We can create a Minikube cluster. So I will start a empty Minikube, and there is a couple of steps. I think this is public, so after the talk you can check this out and try it by yourself. So I will start a vault. There's very simple configuration here. So I can show you the configuration here as well. Maybe I will start a terminal here, and this will be easier. So here we have a vault in Kubernetes. So there is just a simple configuration with just one instance. So let's install. Oh, I will wait until, yeah, we have Minikube. So let me check it. kubectl get nodes, and we have like single node here. We will install the vault, and I will put it here. Okay, so we have a vault. kubectl get pods in all namespaces, and you can see here we have the vault. It's creating. Maybe I will start K9s. It will be easier. So I'll start K9s, all the pods. Yeah, and the pod is running. The vault is not initialized, and it's not initialized and not sealed. I have a simple tool here to create a to do vault init and save the config file. So I will use that. So it's just a vault init command and vault unseal, and it will store the the vault init file here, which is easier for this demo right now. So yeah, vault is unsealed. The setup is stored here. So we have the token here. And now if you see in the K9s, the pod is up and running. I will start port forward. And let's check the vault. So here we have a vault. And it works. Yeah, we have the out again. No, that's weird. Okay, log out, yeah. And if I try this token, it should work, yes. It's empty, so there's no secret store. You can see here in the access authentication methods, there's just the default token. So let's set up the vault. And I don't want to do it manually by ClickOps. I have a Terraform for that. So let's go here and see the Terraform. I will copy this because I will need the token for the Terraform. And here there is a vault Terraform, and I have some configuration here. So at first I will update the token here, and I will show you what's the configuration for this integration. So maybe I will increase the size. Here we have a Kubernetes out. So I will enable Kubernetes out backend on the default path Kubernetes, and I have to connect my cluster for that backend. So here I will specify this Kubernetes path, and I have to provide a Kubernetes API host. And if I have a in-cluster vault, I will leave the token reviewer empty. It will use the reviewer from the pod, so that's easier. This is the Kubernetes connection. I have also a role here. So this is the role mapping. So in my case, I have some Postgres example with Postgres password. So here I have a read Postgres password role, which I will be using from the cluster, and I will bound this service account. So just default. I don't want to create custom service accounts. I will use just defaults in some namespaces. So I will authorize the namespace default, example1, and Postgres. And this token will have the policies, and the policy is just a read of this Kubernetes/Minikube/Postgres secret. So that's it. If I am in these namespaces, I can obtain this secret from the vault. And that's basically it. I have some extra things like custom user, custom admin, because if I refresh the UI with the token is not cached, so much easier is to use a user pass, and the last file is just this user pass configuration for the authentication backend and for single user. So let's apply that. I have some old state, so I will remove that state because I have a new instance of Vault. So yeah, I will go here and I will apply that Terraform. So Vault Terraform init, Terraform apply, and yes, and I've created the configuration for the Terraform. And one more thing, I've created a secret for the key value backend. So if you go here, we can now use admin, And yeah, it's pretty unsecure. And as you can see here, we have a Kubernetes authentication method, which is crucial for our example. There is the user pass, which is not necessary for this demo. And we have a secret. This is a key value secret engine without any secrets. We can also create secrets using Terraform, but the secrets are stored in Terraform state, which is not ideal as well. So we have like a super simple tool for that. We call it a vault filler. So here in vault secrets, there is a simple configuration. And here you can see we want to provide this kind of secret, and we have some configuration, for example, ask for the secret, or if this is a Postgres password, we can automatically generate it. So just a generate password and it will generate it. So then let's put the secrets there. So in this case, let's log in into our vault. So here I will go to the vault secrets, log into the vault with the proper configuration. So I will use this one. And here, yeah, we have to log in into vault. I hope. No. Yeah, the port is forwarded, so yeah, it's a bit slower, but it seems to be fine. And we will run the filler. So I will run this, and it basically automatically generates the password for me. There is no state for this command. It's in our utilities. It's super simple stuff. If I create the secret manually, it will be the same. So here in the secret, if I refresh it, you can see Kubernetes, Minikube, Postgres, and that's it. So I can also create a secret like this, and it's basically the same. So we have the secret here. If you can see here, we have our Postgres password. It's automatically generated. It's fine. So let's try to get the password in the Kubernetes without any like static secret configuration in our Kubernetes example. So in the example, I have a Postgres. I will start with this Postgres first. And here, if you see, there is a stateful set. There is no storage. It's super simple. And we want to get the Postgres password in the environment. And here, we can use value from and choose the secret. In this case, it can be much simpler. It can be just env from and read all secrets from that secret. In this case, there is just one, so it doesn't matter. So yeah, we want to read the secret from the standard Kubernetes secret, Postgres env, and we don't have that secret. Instead of secret, we have this external secret, and I have a secret store and external secret here together because I don't want to use like global one. I want to use the specific one only for the receiving the Postgres password here. So in this case, we have a secret store, and we are connected into the secret using a Kubernetes out. We can use different authentications here. So if we need from just a token, we can also use just the token here, but we are missing the whole point about the secrets in Kubernetes like files. So here we will use a Kubernetes out. The mount path for the Kubernetes out is Kubernetes, and this is our role. We can check the role also in the vault. So if you go here into access Kubernetes out, we have those two roles. Here is the Postgres row. I can see the row, and you can see there are the namespace, there are the service accounts, and there will be somewhere the connection to the policy, and the policy is here. So ACL policies, read Postgres password. This is the policy. So this is our secret store. We will use a service account default, and then we will create an external secret which will mirror the secret into the Kubernetes cluster. And we will choose the secret store. In this case, is same name. And there is a data mapping. And in this case, also we are mapping a single item from this key. So if there will be like multiple keys in this Postgres, we will map only the Postgres password. That's it. So let's install the external secrets operator and then try this. So in this case, I will go back here, and we have the external secrets operator. There's just Helm install without any configuration necessary. So I will go here, install it. You will see new pods for it. I hope. Yeah. And we can wait until the operator will be up and running. And then we can create a external secret and check if the secret will be created. I hope the internet will be good for it. But yeah, we will see. And then we can create the rest of the Postgres, and it will be fine. Let's check if there is some trouble, but I think it's just a image download. So describe. Yeah, we are just pulling those images. So I hope it will be fast or faster. Yeah, it's running. We are waiting for the readiness probe, and I think it will be ready soon. Okay. This is okay, and yeah, perfect. Everything is up and running, so let's apply the Postgres, and I will create a namespace for the Postgres example. I will create all those namespaces together. Close this. So here we have all the namespaces. I can switch to the namespace Postgres and apply the configuration. So example Postgres, and I will apply the external secret first, and let's see how it's done. I can get those objects, so use get, and as you can see here, we have a secret store. You can see it's valid, so the connection has been established to the vault, and in this external secret, you can see the sync status, so the secret has been created. So let's check this, kubectl get secret, and there is a Postgres env. So if I show you secret, here we have the secret and the password is there. So that's quite nice. And the rest is pretty straightforward. kubectl apply -f example Postgres, and I'll apply all together. There are some unchanged stuff in the secret stores, and now we will see if I go to pods. We are running the Postgres. There's also like image download, but there is no container creating error because everything works. Let's create kubectl create namespace Postgres2, and kubectl apply everything into namespace Postgres2, and let's see what happens. Here we have a create container config error. The error is there because we don't have the secrets there, and why we don't have the secrets? It's because the external secret cannot access the vault because we didn't authorize the Postgres2 namespace for the role. So if I show you secret store, secret store, you see two of them. This is the valid, this is invalid provider. If I show you describe, you can see it's not authorized, so it's the valid behavior. Same for the external secret. This one, external secret. You can see here, this is the synced. This is not synced because the missing namespace in the configuration. So this is the first way how to synchronize the secrets using external secret operator. You can use many operators like this, for example, the vault secret operator. And the other way is use the configuration in your app directly. So I have the second example here. So if I show you the other example here, we have like a counter application. It's my GitHub Ondrej Sika / counter. It's like application demo for like my Kubernetes trainings. And here we don't have any external secrets, any environment from secrets. We have some static environment configuration for our application. So we will use a Postgres as a backend. The Postgres is running in the service Postgres in namespace Postgres. And then we have a connection configuration for the Postgres password in the vault. So our application has a vault integration built in the Go. This is Go application. The source is on GitHub, and we want to source environment from this secret, and we also want to use the same role. So in this case, this read Postgres password as well, and the rest is standard application deployment. And we will deploy the application. So I will go back here, and I will use this deployment into the namespace example 1. And if I show you the canines here, pods, you will see the application is starting and it should run. We have to wait for the image pool, so we will wait a couple of seconds. Then I have the another example, just install the same thing into the namespace example 2. And if I show you the configuration of that role here in this role, we have only namespace default, example, and Postgres. So in the example 2, we will have the same trouble as in the Postgres 2 in the previous example. So now you can see everything is up and running. You can see the probes are fine. So try to port forward the application. And if you go here, you'll see application is running. It's connected into Postgres. The counts are stored in the Postgres. It's a pretty simple app. And let's try to deploy the same application into the wrong namespace. So I will go here, and I'll apply it here, and let's see how this works. You can see some errors, so check the logs, and if you see the log, there is a error message. So we are not able to connect into the vault. Now our namespace is not authorized, so the application just fails, and it fails multiple times, and you can see some crash loop back off. Yeah, it can be better error handling for the application, but for this demo purpose, I think is okay. So this is the general idea how to use a vault or some external secret provider inside Kubernetes with Kubernetes authentication. So if I go back here, the summary of my talk is this is, I think, simple solution, and it's built on proven technologies. We can use HashiCorp Vault, we can use OpenBOW, and many other things. You can use your applications, your Helms with no or little changes. If you have like hard-coded secrets, even in those deployments, you will just, for example, use the environment from and mount the secrets from some secret, and that secret will be provided by external secret in this case. And it's great for GitOps because in all the Kubernetes sources or in all the Terraform source code, there is no sensitive information anywhere in Git, so that's quite nice. So this is the link for the demo. It's in my GitHub. So if you just go to GitHub/Ondrej Sika, there will be, I think, on the top of the repositories right now. And that's it. Thank you. And if you have some questions, just ask.
Thank you so much, Ondrej. There's actually a couple of questions already, so
Okay.
I think I can read it out loud as well. So why still use Vault when they shift to BCL license model from open source one? Isn't it better to use tools like in physical, especially on CNCF open source events?
We use Vault because most of our clients use Vault and those HashiCorp tools. And I think if you don't like HashiCorp or IBM or the license change, you can use OpenBOW and it will work basically the same, exactly the same. In some of our clients prefer OpenBOW, so we switch some clients to OpenBOW. In some cases, we also switch Terraform to OpenTofu, but right now we are still using both, and we didn't decide any branch. But I think we will probably go with the open source one. So that's it.
Cool. Well, thank you. Fair enough. It's consulting after all, right? So,
yeah. But in this case, I think like the Tofu and Terraform and BOW and Vault, I think the split has one great advantage after all, and it speed up development on both sides. So the new features in Vault or in Terraform were pretty slow before this split, and now it's much faster.
Yeah, definitely. The next question is about what about Vault injection, sidecar of the bot, which will inject the secret from Vault directly to the bot. What do you think about this approach?
Both approaches has own advantages and disadvantages. I think this the injection to the volume is great if your application can read the secrets from some like file system, and you don't have the secrets in environment variables, which is in some cases better. But if your application just needs a environment variables, or if it's like third-party thing which requires a secret object, for example, if you need a TLS for ingress controller, you can use this. And I think it's much easier with the secret mirroring. And yeah, you can read the secret from the Kubernetes API, which is also disadvantage. So yeah, both approaches has own advantages, and we use this one because it's, I think, easier in many cases. But some clients want the injections, or even the injection has, I think, couple of security advantages, like from the if you have like frozen file system, nothing in there, it's, I think, a bit more secure. But yeah, if you are in the cluster, you have the identity from the cluster. I think, yeah, you can receive those credentials anyway. So yeah.
Thank you. Are there any questions from the audience live? Anyone? Just in Slido. There's some in Slido, of course, but all right. The next question. Sometimes it's inevitable to avoid static secrets, especially from or for some third-party services. How would you manage those with Vault?
Yeah, this example is the exact example with static secret. If I get back into the vault here, this Postgres password is not the Postgres integration in Vault. This is just a static secret. So I just map this exact static secret to the Kubernetes, but the Vault has multiple secret engines. So if I add some secret engines, for example, for the database, for the Postgres, I can receive like a one-time password for the Postgres, but in this case, in this example, that was exactly the static secret somewhere involved. So it's not ideal. If we can use some short, some one-time password, one-time secret for anything better than this one. But in this case, yeah, this is static Postgres password. Okay.
All right, thank you. The HashiCorp Vault license is expensive. Is there a cheaper way to do high availability?
OpenBAL.
Okay, OpenBAL, okay. And how to handle an app that expects the dot properties file attached as a volume? Is there an operator that creates such file based on Vault values?
Yeah, there is an operator. The Vault operator can use exactly this. Or if you expect the secret attached as a volume, you can also go to the Kubernetes manifest here, and instead of this mapping like secret to environment, you can create a volume from that secret, and it works basically the way you want.
Okay, thanks. Nice. Right now there are no more questions in Slido. Are there any questions in the audience? Okay, if not, please, once again, big applause for Jay.
Thank you.
Thank you so much for your talk.
And I will be in the booth, so you can go there and talk about anything. Basically.
Definitely, many questions that always follow afterwards.